And this is my demo project for NAE 535. My demo project is the Linear Variable Differential Transducer, or LVDT. And the most common application for this is position sensor. A position sensor can be used in several different industries. Manufacturing uses them, robotics, medical fields even. And the one I'm most familiar with and will use as my example is flight control systems. So the way that the LVDT works is through Faraday's law. I have this mock-up here of the internals of the LVDT. Faraday's law is that a time-variant current will create a magnetic flux, which will in turn create a current in a nearby coil. So we have our center coil, our primary coil, that's hooked up to an alternating current, and as that current flows through the coil, through the center, a magnetic flux field starts to build. And as that magnetic flux field builds, the coils that are on the outside will start to induce a current to counteract that magnetic flux, get them back down to net zero where they were happy. And to further enhance the magnetic flux that is created with this sensor, you add a ferromagnetic coil, and that will increase the order of magnitude of the flux field by a large amount. You center the core, and the induced voltages are balanced. But as you displace the core from one side or the other, the voltage that's induced is unbalanced. And when you take the difference between those two voltages, you get your output voltage that is sent back to your controller, maybe your flight control computer, and is relayed along, eventually translated into position. So we'll take a look at the LVDT that I have set up to the oscilloscope to illustrate this further. Neutral position, the core is positioned so that it's basically balanced between the two sensing coils inside the LVDT. But if I'm a pilot and I have my LVDT attached to my surface actuator, I'm going to send it a command that says I want the actuator to extend. And to make sure that that's happening, it gets a feedback from the LVDT. And as the LVDT and actuator extend, you get a higher and higher voltage amplitude. And the maximum I like to go is about there. So if I pull it out all the way, it doesn't want to go back together pretty easily. If I want to now change directions and send it the full way, all the way in the opposite direction, you send your actuator moving and your LVDT with it, and now the voltage amplitude drops until it gets back to the neutral position where it changes phase and starts growing again. So you get a phase that can show your direction of extension or retraction, and you have your amplitude, which tells you how far you've extended or retracted. So this is a predictable linear relationship between voltage and position, and basically each voltage that's sent is translated into a different position by the flight control computer, so that it always knows where that surface is and what it wants, what the flight control computer wants it to do next. So thank you.